Alright, I am back from course week and we have an A1990 in front of us. Let's plug in the charger. And we're getting 5 volts and 0.1 milliamps. Now this device was checked prior by other technicians if it was in DFU mode, and it is not in DFU mode. So we could have a few things going on. We might have a bad CD3217, we could have a short on PP bus, we could have a short on PP3B42, or CD3215, not the CD3217. So the first thing I want to do is see if we're getting voltage on PP bus, because that'll tell me if our one of our CD3215s is allowing charger DC and voltage through, and it is 0.2 volts. Okay, so we're going to try another port. Let's see if our voltage changes, and it does not. So now we're probably going to be looking at an issue. Something's up on PP bus. So most commonly we'll get it as a PP bus short, and we have a 3.7 ohm short to ground on PP bus. So this board has to come out of the enclosure now, and we will try and see what's going on with this. Okay, I just pulled out the board and immediately I could see probably what our problem is. So let's go ahead and look through our microscope view, and this again, this is just visual inspection, and look at this. We have an internal short right there, and that what happened was that capacitor got so hot that it most likely just burned the underlying PCB right there. So that's not a good thing for sure. So I'm going to try and just take this out of here real quick and see how bad this is under here. Yeah, this got hot. Alright, this isn't that deep for sure. This is corroded right there, so this has got to go. Let me go grab a donor board real quick. And the first thing I'm going to do is get all the corroded nasty stuff off of here. So this chip's gotta go. Chip is probably fine. Yeah, look at that. Alright, it's time for an X-Acto knife, and we're going to remove this short. Alright, so I'm just going to make a little cut right here. Just like that. Anywhere that looks like it's internally shorted, and I'm pretty sure I cleared it. Get a little bit more around this via here. Yep, that should be cleared pretty well. Don't want any of these layers to be touching, obviously. There, I think that will be good. Now let's recheck for our short. And we're actually worse off now. We're 0.6 ohms to ground. So more digging. It's probably touching right here. Let's look really, really closely. Yeah, right here, I'm sure. Or under here more. Let me go get a new blade. This blade is kind of old. Trying to remove all of this that looks bad, especially right around here. Want to leave a little margin too between this top layer and the layer adjacent to it, because this is PP bus right here. And this is ground under here. Looks like right under here maybe. Alright, that's separated. This isn't good right here. This via might be, yeah, this is in there pretty deep. Let's check again. .4. Have to go layer by layer now. This is the part that really sucks, because this is probably where our short is. I'm trying to remove this pad here. That capacitor, we're probably going to need that to generate whatever is connected to this. It's probably an SSD rail or something. So I'm going to have to put that back. But for right now, I'm just going to kind of remove this pad. Little leaded solder to make it easier to wick away. More heat. All right, now we could, a little bit better area to work with here. Anytime a board is internally shorted like this, we usually do not ultrasonically clean it, because it tends to make it worse, and this is a data recovery only job. So we're not going to ultrasonic it, because that's gonna, you can introduce water into the layers of the board by doing that, and it makes your problem a whole lot worse. So now we have a better area that we can work with here and try and clear this out. So let's look. So I want to kind of cut this way. I need to make a bigger area to work with, so I'm going to remove this top ground layer. Just slowly. There we go, we're under it. I could kind of just cut. That's what I want. I want that to peel. This is just ground here, so it's not important. We need to get in here to remove this, so it's really helpful if we can get our knife under the layer. It can be hard to do sometimes. But we're getting there. Just like this. And somewhere an Apple engineer is watching this and totally losing their mind. But that's okay, because we are going to save this board and get this customer's data back. A little bit more. Now this is probably a power layer right here, maybe PP bus, I'm not sure. Clean this blade off a little bit. Now we can cut again, just like this. Yeah, here's where our problem is. It's right in here. Sometimes it helps to put a little alcohol down too, so we can see better in there. Increases glare, but it'll help visibility. I mean, increases glare for you guys, but it helps visibility for me. You can see our little tunnel down here. Still touching in a couple areas. There we go. Alright, now I could remeasure and see if our short is gone, because I think I cleared it. I think it was right in there. With any luck, this will be the same 0.6 ohms to ground. Okay. Let me try and localize it. Let me see what I'm dealing with. So I'm going to just use a little bit of power here and see if I can figure out where this voltage is coming from. So I'm going to go down to like 1 volt. This is on my DC power supply. And we see it steaming, but where? Looks like right here. See this? Look, I'm touching it. Right in here. Okay? Oh yeah, I could see it right here. Right here. This is where it was. And right here, looks like. Cut again. Now let's see. Yep, it's gone. At least on DC power supply, pulled no amperage. Now let's see what we get. And it is, moment of truth. $200 ohms and climbing. It's probably some residual charge in the capacitors. I'm going to switch to diode mode for this. 0.5 and climbing. Alright, we may still be partially short, we may not be. There is probably some residual charge in these capacitors, so I could try and maybe discharge these. Anytime you have charge in the circuit, that can affect diode mode and resistance readings, so I'm going to just try and short this a bit. And now we'll try again. resistance mode. It's above 200 ohms. That's still, I would consider, okay, now it just went. Yeah, this is, I would say this is partial short still. So something else here is up. But the question is will we be able to turn on like this? Is there, oh, maybe this has something to do with it. Maybe. This too, this might be on PP bus. So I'm just going to go get off my board. I don't need you. There's the capacitor, and this one's knocked off too. I probably just did that right now. Anything else that looks off that might be partially short? Nope. Alright, so check again. Alright, 200 ohms to ground. Again, that's definitely higher. That's definitely lower than I would like to see. But since this is data recovery, I think we'll be okay. Yeah, I'm just checking on a known good board, and it's in the kilo ohms. So, yeah, I'm not going to worry about this too much unless we could see here there's something that might be still touching. Could be just a little piece of something here that's still hanging on to PP bus, and I would rather clear it fully than proceeding, because sometimes if it gets hot enough it will melt, and then we have a much bigger problem and the board will not be recoverable. So I really would like to see this have higher resistance. So I'm going to try and just look really hard at this. Let's see, maybe there's a little nub right here. Hard to tell. Right here, maybe, for sure. Internal shorts like this that you excise, it is incredibly easy to make it worse, so gotta be careful. I'm gonna flush this out real quick. This is just alcohol on a 23 gauge syringe that I'm just flushing the area to get all those metal particles out. Yeah, and it's hard to see. You probably won't see this on camera, but you see how, like right in there, it appears to be touching on a layer? That's what we don't want to see. Let me point this out with the needle. Yeah, like right there. Right where that needle is. It's touching. It's no good. Now it's totally fused. I'm going to cut again. There we go. It's free right there. Cool, cool. It's gone. At least right there it is. Oh, we have a visible crater in the board there. It's okay. What I'm going to do now is check again, and if the short is totally relieved, I'm going to start by conformal coating this and putting back our stuff that's missing. And there we go. It is totally relieved now. We are in the kilo ohms. Awesome. So I'm going to do a quick rinse right here with just some isopropanol alcohol. I don't need, the syringe is too small and won't deliver enough volume, so I just need to rinse it. and then we'll be right back and we will conformal coat this and start by rebuilding the board. Now we do have some areas that had some knocked off components. When I flick that cap off this one, so this resistor is going to be a real easy place back, so I'm going to just do that right now. I could probably do this with my iron. It's aligned pretty close. Good enough anyway. Internal board shorts, I always try and get back full functionality, but they're generally regarded as data only. This particular device here, this is a data only board, so it doesn't matter too much. It is an absolute mistake to ultrasonic a internal short board, because you will introduce liquid in the layers and you will probably turn the board into something that's not recoverable. So just a word of advice there. I know from doing it. There, that's soldered back. This guy I'm not even going to worry about. So now we can dry this area off and we will get some conformal coat in here. So I just want to make sure all the liquid is gone, so I'm going to heat from a distance just to dry out the layers there. And that should be good. Grab some conformal coating. I'm using this Mechanics UV coat, which is actually, they have green, black, a whole bunch of different colors. I'm going to use black because it kind of blends in with the natural PCB there. Thin layers I'm going to apply this on. So I have a little bit there. I'm going to spread that around. Just like this. Just want a nice thin layer covering anything that looks ugly. This is to seal and protect it. That's pretty good for my first layer. I'm going to cure it. This nice, really powerful UV light to do this. It's a USB light that you can get on store.iPadRehab.com. I think store.iPadRehab supply store. But this light is very, very bright, and it will cure this coating in a matter of seconds. Alright, this first layer is done. I'm going to put some more for our second layer on there. So I want to focus on the edges here. Anywhere that's kind of exposed. Just like that. Spread this out again. Like that. UV again. Alright, it's time to start rebuilding our board. So I'm going to get a little bit of flux down. Now that capacitor right there is for PP bus smoothing on our MOSFET for this rail. So I am going to try and put that back. There's certain capacitors you could just leave off. That one I believe is going to be a bootstrap capacitor, so that's going to be important, or else our MOSFET will probably go on fire. This is an ISL 95870 or something. This one, we're going to use a different revision of this chip, but it's the same chip. So let me see if I can get this capacitor on here without causing any damage. I don't like to do this when it's this close to an internal short, but this particular cap is kind of important. So let me try and get this cap on here. The little one right beside it is not important, so I don't care. Not the prettiest, but it'll work. Now for our chip, I want more solder on these pads. Oh no, I ripped the pad. Is it no stuff? Let's look. It's probably a no stuff. Alright, this is our enable line, so we gotta try and fix this. Not a big deal. Just gonna turn this and let's see if I still have my enable. Or continuity to the enable chip right over here, and if so, we're going to leave it alone. And we do. Good. Now for our chip off of our donor board, let's get orientation here. Gonna go with the dot. Got it. Okay. Wait a second, this doesn't look right. The schematic lie to me? 1, 2, 3, 4, 5, 6, 7, 8. 3, 6, no. This is right. I'm gonna double check before turning this on though. No, that's correct. Alright, that's soldered. Another little cap right here. I'll throw this guy back on. That's for PP bus again. I'd rather not heat this area too much because that internal short. So this little cap right here can stay off for now. That's soldered. That looks good. Now let's just double check for PP bus short. Like, yeah, little decoupling caps, it's all about risk. In that case, I'm not going to risk putting a little cap on there, because that's just a decoupling cap. That one's not important. And no short. Now, the real test, does the device boot up? Alright, our board is back in the enclosure. Screws are not in it. It's just set in here. I'm going to plug in my USB-C and see what we get. So we got 5 volts before. We are getting 5 volts. 20 volts and 16 milliamps, and we get a spinning fan, not a finning span. Fan spin. Now do we actually get boot? That's an Apple logo. Check that out. So this is an Apple logo. Come on, boot to OS. Boot to OS. You could do it, little MacBook. Boot to OS. Come on, I know you can do it. You're booting in recovery, aren't you? This always happens. Hey, look at that. This is a fixed MacBook with an internal short cleared. So, very important. This data needs to get off of here ASAP. So we're going to transfer the data, and then this is done. So this was a data only job, but the customer should get back a fully working MacBook. So thank you for watching, and I hope this video helps you dig out your MacBook PCB if the need comes to. Thank you for watching.